All right, hello everyone. Thank you for tuning into my talk. My name is Stephanie Schmidt. I'm a graduate student at the University of Illinois, and today I'm going to be talking about some of my thesis research, which is looking at the effects of water drawdowns on marsh bird nest survival at Emiquon Preserve. So first I want to start out by talking about why marsh birds. Well, marsh birds are a group of wetland-dependent water birds that include bitterns, herons, rails, and grebes. Marsh birds are often typified by their habitat associations, their cryptic plumage, their sneaking behaviors, and their infrequent vocalizations. Unfortunately, these qualities have contributed to marsh birds being greatly understudied and undersurveyed, especially in some of those classic roadside surveying efforts, which rarely venture into wetlands. And this is proving to be a problem because according to a 2019 study by Rosenberg et al. In the journal Science, we are seeing that marsh birds are experiencing widespread population level declines. And one of the leading causes of these declines is habitat loss. Unfortunately, wetland loss and degradation is something that we are all too familiar with here in the United States, and especially here in the Midwest. So this series of maps here depict the 53% of wetland acreage that was lost in the United States between the 1780s and the 1980s. And here we can see that the Midwest has experienced substantial wetland loss during this time. And the majority of these losses were driven by land conversion for agriculture, with Illinois being one of the hardest hit states. So by the 1980s, Illinois had lost around 90% of its historic wetland acreage, and the majority of these losses occurred in the northern two-thirds of the state for both agricultural expansion and urbanization, especially around the Chicagoland region. Today, the vast majority of remaining wetlands in the state are small and isolated and less than 100 acres in size. So this has prompted the need for wetland management and restoration, and one of the management actions that is taken is controlled dewatering, or the removal of water in wetlands in the spring and the summer months to introduce disturbance and reset wetland stages. And this management is used across the nation in floodplain wetlands, landlocked impoundments, prairie pothole wetlands, and even coastal wetlands, and it can be used alongside various other management practices such as disking, mowing, herbiciding, or birding. It's also been found to be widely beneficial to a range of plants and animals. So when water is pulled off of the landscape, this creates mudflat habitat that proves to be wonderful foraging habitat for shorebirds. It also allows for greater mammal movement because some mammals may be typically deterred by deeper water, so then they're able to access the marsh interior and resources that would have been inaccessible to them before. One of the largest benefits of this seasonal dewatering is that it allows for the germination of moist soil plants, which will eventually produce high energy seeds that feed fall migrating waterfowl. It's also beneficial for controlling movement of invasive fish and amphibians and for recharging groundwater. And in the year following a drawdown, we're going to see the creation of more emergent marsh habitat, which is wonderful habitat for our marsh birds. These drawdowns, however, do come with risk, and that risk is most often the risk of predation due to these changing habitat conditions. So predation accounts for around 70% of reproductive losses in all bird species. And that's really important for us to consider here, especially with our vulnerable marsh bird species, as reproductive losses can have long-term population level effects. So when water is removed off of the landscape, the first risk that comes with it has to do with water depth. So marsh birds select to nest over water because it provides access to food resources such as fish, amphibians, or aquatic invertebrates, and it also provides protection from terrestrial predators who are typically deterred by deeper water. What we see is that if water is pulled off of landscape while marsh birds are nesting, the water below the nest will become more shallow, the water's edge moves closer to the nest, and ultimately we see greater access to the nest by these terrestrial predators. The second risk that we're concerned with has to come from vegetation height, structure density, or composition, which ultimately aid in nest concealment. So marsh birds want to nest in sites that offer the most concealment because greater concealment means greater protection from predators. But if these water drawdowns have the ability to change vegetation composition between years or even disrupt current growth, we may see that marsh birds are nesting in sites that offer less concealment and therefore put them at greater risk of predation, this time more so by aerial predators. It's also important to note that risk is not solely explained by habitat factors, but can also be a product of the predator community that is present, and not all predators are equally impacted by every habitat variable. So now speaking about water depth, I was more so concerned with terrestrial predators, vegetation height and concealment, I was more so concerned with aerial predators like hawks or eagles. So for this reason, many studies have begun to use cameras at nests to collect insight on predator identities, partial predation events, and incubator activity to determine nest success in response to an environmental impact. And these cameras have been used to answer these sorts of questions in wetlands with black terns, whooping cranes, and waterfowl, though they have not been used extensively. So before cameras were used to identify predators, scientists had used marks on eggs, tracks around nests, or nest condition to identify predators, so it's been found to be relatively unreliable in comparison to these camera studies. So this now brings me to my research goal, and the goal of my research is to use marsh bird nest survival and predation risk to better inform wetland management practices for marsh birds. And my first objective is to address species-specific nest survival at marshbird nests where predator identity is ignored. And my second objective is to address predator-specific predation risk at all marshbird nests where predator identity is confirmed, here using those small video cameras at nest sites. So this research was conducted at Emiquon Preserve, which is pictured here in central Illinois along the Illinois River in Fulton County. And Emiquon Preserve, or the Nature Conservancy, implemented two very different drawdown approaches in 2020 and in 2021 when this research was conducted. So in 2020, they opted for a more early season high intensity drawdown, pulling around 4.5 feet of water off of the landscape between June and August. And as we can see here, these drawdown dates appear to overlap with some of the peak nesting dates for marsh birds in the area. In 2021, they opted for more low intensity late season drawdown, pulling only 1.5 feet of water off of the landscape between July and August. You can see this sits just outside of some of these peak marsh bird nesting dates. So in this study, we selected 4 marshbird species to observe, and these 4 species have been commonly found at Emiquon Preserve for the past 7 or 8 years and have varying levels of concern, with 3 of the 4 listed as state threatened or state endangered. So the first species we looked at was the least bittern, which is a small cryptic heron species that builds elevated plate-like nests on vegetation edges and over deeper water. The second study species is the American coot, which is a common native diving rail that builds floating platform nests. The third study species is a common gallinule. This bird is incredibly similar to the American coot, but unlike the American coot, it can build both a floating platform nest as well as an elevated plate-like nest similar to the least bittern. And at Emiquon Preserve, its common nesting strategy was that elevated plate-like nest. And our fourth and final study species was the black-crowned night-heron. And this bird is a colonial heron species that builds nests in rookeries, either in trees or in dense cattail islands. And at Emiquon Preserve, it opted for those dense cattail islands. So we surveyed for nests of our study species at 157 randomly selected plots in dense emergent vegetation and hemi-marsh conditions between 2020 and 2021. And in total, we found 293 marshbird nests. Of these, 158 were active and were used for the subsequent analyses. When we found a nest, we marked the nest with GPS coordinates and flagging tape to aid in locating the nest for revisits, and we returned every 3 days or every 5 days to document fate. The reason being for coming back every 3 days versus every 5 days was to look at how human activity or disturbance around the nest site may be influencing nest fate, and ultimately we found that to be insignificant. At each nest revisit, we also collected a set of spatial and temporal variables, which included water depth, average emergent vegetation height, distance to shore, year, nest age, nest stage, and day of year. And we stopped visiting a nest if it was completely predated or abandoned, or if hatched juveniles were unreliably at the nest. Finally, we set up continuously recording cameras at 80 of our marshbird nests to document nest activity and identify predation events. With our cameras and our predator-specific study, we were able to document partial predation events because failing to record them could ultimately underestimate predation risk in the end. We also didn't want the cameras to have any significant effect on nest fate, so we concealed the cameras using paint and vegetation and tested their effects with a statistical analysis. And ultimately, we found that the influence of the cameras did not have any statistically significant effect on fate for the majority of our species, but it did appear to be more linked with abandoned nests for common gallinules, which could suggest that they may be more sensitive to novel objects or disturbances around their nest site. So next we divided our variables into our spatial and our temporal models, which can also be thought of as our habitat or our activity models. So studies have found that nest activity does not necessarily increase predation risk on its own, but it could increase predation risk when it's coupled with habitat variables. Hence why here for our temporal or our activity variables, we have also included our competitive spatial models. So essentially what that's saying is that predators need to first have access to a nest site before they can then pick up on those activity cues. We then use these spatial and temporal models to address both objective 1 and objective 2. And first, we're going to start with objective 1. This is where predator identity is ignored, and we're looking at species-specific causes of nest fate. I will say before we start, we're not going to talk about American coots individually, because between the 2 years, we only found 1 active coot nest. And we're also not going to be talking about black-crowned night-herons today in the interest of time, and because we also worked with a very small sample size there, and we're unable to reach any conclusions, they're really wholly informative for management. So what we're looking at here are least bitterns. And for least bitterns, we found that water depth and year were significant predictors of nest fate. And what we're looking at here is a daily survival rate graph. So on our y-axis is our daily survival rate. Values closer to 1 means it's more likely to survive, 0 more likely to fail. X-axis is our variable of interest, which here is water depth. And what this is telling us is that nests in deeper water and in the year of 2021, which is that late season low intensity drawdown, these nests are more likely to survive than nests that are in more shallow water. In the year of 2020, they're that high intensity early season drawdown. We also found for our least bitterns that distance to shore was a good predictor for nest fate, seeing here that nests that are further from the shoreline, and again in 2021, the year of that late season low intensity drawdown, we're more likely to see least bittern nests surviving than nests that are closer to shore in the year of 2020. For common gallinules, we only found that water depth and year were significant predictors of nest fate, seeing here the same relationship we saw with our least bitterns. Greater survival in deeper water and greater survival in 2021, the year of that low intensity late season drawdown. So next we addressed objective 2, and this is where predator identity was confirmed in our video cameras. And here we observed mostly edge predators, or predators who are using habitat edges to help facilitate their movement or aid in their camouflage or thermoregulation, such as raccoons, mink, and fox snakes. And it's important here that we saw so many edge predators because dewatering can essentially link marsh edge with marsh interior, which creates a greater habitat overlap between habitat that our edge predators are going to be using and habitat that our marsh birds are going to be nesting in. We also observed 5 avian predation events by black-crowned night-herons, brown-headed cowbirds, common gallinules, and marsh wrens. And with our avian predators, it's important to note here that we only ever observed egg breaking, never birds consuming these eggs, which may suggest that this is more a territorial behavior and less so a predatory behavior. We also observed 18 losses in the other category, which is defined as abandoned nests or nests that are lost to unknown causes. And we opted to include abandoned nests where an incubator had been confirmed because abandoned nests may be indicative of risk around a nest site without actually resulting in a physical loss at the nest. So first, we investigated variables that are contributing to mammalian predation risk, and here we found that water depth and year were significant predictors. And it's important to note here, we're no longer looking at daily survival, it's now daily predation rate. So essentially the y-axis is just flipped. And what this is telling us is that nests that are in more shallow water, and in the year of 2020, the year of that high intensity early season drawdown, we're more likely to see predation by mammal predators. So essentially what we're seeing is that water is pretty effective at deterring mammalian predations. So before drawdowns, our mammals are going to prey on nests that are occupying that same dry or shallow water edge habitat that they're using. But following these water drawdowns, we're going to see a greater expansion of that usable edge habitat for our mammalian predators towards the marsh interior. And with that, we see greater access to the marsh interior and greater predation risk there as well. Next, we investigated the causes of reptile predation, and the only reptiles that we observed were fox snakes in 2020, hence this greater predation risk observed in 2020 as opposed to 2021. And we believe that these relationships that we're seeing with fox snakes are less related to drawdown timing and intensity, but more related to the landscape of the marsh in spring and behaviors of fox snakes. So fox snakes are generalist predators who use their edge habitats. They're also very capable swimmers, so they're not typically deterred by deeper water, but they do avoid wide open spaces as these don't provide protection from their own predators, which are oftentimes aerial predators, and they're not really conducive to thermoregulation. So what we're looking at here is the starting water depth in May of 2020 and May of 2021 at Emiquon Preserve. And this is an important time because this is around the time that the marsh birds are returning to Emiquon, looking at the landscape that is present and deciding where they want to nest. And it's important to look at this here because in 2020, Emiquon started out much deeper. So we saw that the edge vegetation surrounding kind of the rim of Emiquon Preserve was inundated, and it created wonderful nesting habitat for our marsh birds in 2020. But this is also going to overlap with edge habitat that our snakes would have been using. In 2021, however, Emiquon started out much more shallow, and we didn't have that edge vegetation inundated. And the only inundated habitat for our marsh birds is actually way towards the marsh interior right at the center. It was only accessible by passing through wide open expanses of open water or mudflat, which is something we don't believe that the fox snakes were likely to do. So essentially what we were seeing with our fox snakes in 2020 was that before the drawdown, fox snakes are preying on nests that are occupying that same vegetated edge habitat that they're using. But in 2021, we're seeing that all of these nests are more conglomerated towards the center of Emiquon Preserve. And we don't believe that our fox snakes were likely to head towards the center because of this greater perceived risk of predation. And they were likely to remain in that vegetated edge habitat. And as a generalist, they can find alternative food sources. So essentially what we can conclude from the study is that water appears to be very important for nest survival, and it provides significant protection from mammalian predators. So by retaining water on the landscape during these peak nesting periods, which was exemplified in 2021, the year of that low intensity late season drawdown, we may see greater marsh bird nest survival and less predation by mammals. Our study also shows the importance of using these cameras at nests to identify causes of predation and link habitat factors with the predator community to better manage for nest loss of a vulnerable species. As I wrap up here, I do have a lot of people that I need to say thank you to for contributing to this project. I need to thank my master's committee, Dr. Benson, Dr. Fournier, and Dr. Ward, as well as my many field technicians I've been able to work with over the past 2 years. I do need to thank Doug Blodgett and Sally McClure of the Nature Conservancy for allowing me to do my research at Emiquon Preserve. I had an amazing time there. I also need to thank all the staff at the Forbes Biological Station for assisting me with my fieldwork at Emiquon Preserve and my many sources of funding, which are pictured here. I'd now like to open it up to any questions that you have for me. If you have any questions outside of the Q&A period, here's my email. Please feel free to send me an email.